this video, we will be taking a look at using factor trees as a way of finding the product of prime factors for a given number. Before we begin, we should clarify what a prime number is. And a prime number is a number that is only divisible by itself and 1. So there are only two factors. A list of prime numbers would be 2, 3, 5, 7, 11, 13, and so on. And quick note, we do not consider the number 1 as a prime number, as prime numbers need two factors, therefore 1 does not fit under this category, so this list will always begin from 2. Having a look at an example question here, express 50 as the product of its prime factors. Give your answer in index form. Now we need to find the prime factors of 50, so we will need to find all of the prime numbers which are factors of 50 and write them as a product, which means we need to multiply them together. We can do this step by step to make it easy for us. So the first step would be, for our reference, to write down a list of all of the prime numbers. There are more than this, but this will do for now. And next we're going to use something called a factor tree to help work out all of the prime numbers which are factors of 50. Now for this factor tree we need to find two numbers that multiply to give us 50. We can use any factor pair, we will get the same answer in the end, but for now we can do 2 and 25. And in this factor tree, whenever we get a prime number, for example here 2 is a prime number, we will circle it. Now we will carry on with this factor tree until we are left with two prime numbers that are circled. So 25, two numbers that multiply to give 25 could be 5 and 5. And looking at our list, 5 is a prime number, so we can circle both of these, and that is the end of our factor tree. The next step is to write down all of these numbers that are circled. So 2 multiplied by 5 multiplied by 5. Now the question states to give our answer in index form. So once we have our list of prime factors, if there is a number on here which is shown more than once, we need to write it in index form. 2 is only shown once, so we leave this as is. 5 is given twice, so instead of writing 5 times 5, we will write 5 to the power of 2. And that is our final answer. A way that we can check this would be to actually multiply all of these numbers together, and that should give us this number here. So 2 times 5 is 10, multiplied by 5 is 50. So that's how we know that this product of prime factors is correct. Taking a look at another example, express 180 as a product of its prime factors, give your answer in index form. So starting off again, we will list our prime numbers. Now we need to do a factor tree for 180. Two numbers that multiply together to give 180, we could do 2 and 90. 2 is a prime number, so we circle. Two numbers that multiply to give 90, we could do 2 and 45. Two numbers that multiply to give 45, we could do 5 and 9. 5 is a prime number on our list, so we circle. And two numbers that multiply to give us 9, we can do 3 and 3, which again are both prime numbers, so we circle, and we have come to the end of our factor tree. So next we need to write all of these circled numbers out and multiply them together. And again, we need to give our answer in index form. So looking at this list here, we have 2, which comes up twice, and 3, which comes up twice. So we're going to write these in index form. So 2 times 2 is the same as 2 to the power of 2. And we're going to write this in ascending order. So we're going to write 3 next. 3 comes up twice, so 3 to the power of 2. And 5 comes up once, so that is just 5 on its own, and this is our final answer. Again, just as a check, we can see if this is correct by multiplying all of these prime numbers out. So 2 times 2 is 4, times by 5 is 20, 20 times 3 is 60, 60 times 3 is 180, so we know this is correct. Taking a look at the first question, we need to express 24 as the product of its prime factors, so we need to do a factor tree for 24. Now, two numbers that multiply together to give us 24 can be 2 and 12. 2 is a prime number, so we circle. Two numbers that multiply to give us 12 can be 3 and 4. 3 is a prime number again, so we circle. And two numbers to multiply to give us 4 can be 2 and 2. Both of these are prime numbers, so we circle, and we are at the end of our factor tree. So now we need to write down all of the circled numbers. Now we need to express this in index form, so we need to see which numbers come up more than once, and as we can see here, that's 2. 2 has come up 3 times, so we're going to express 2 times 2 times 2 as 2 to the power of 3, and we're going to multiply that by 3, which is just shown once, and that is our final answer. And again, just doing our check, 2 to the power of 3 is 8. 8 multiplied by 3 gives us 24. On to the next question. We're going to do the same thing, but for the number 360. So we're going to do our factor tree. Two numbers that go into 360, we can do 2 and 180. For 180, we can do 2 and 90. For 90, we can do 2 and 45. For 45, we can do 9 and 5. 5 is a prime number, so we circle. And for 9, we can do 3 multiplied by 3. Both which are prime numbers, so that comes to the end of our factor tree. Now we need to write down all of the circled numbers again. And just like the previous question, we need to express this in index form. So we need to see which numbers appear more than once. So starting off in ascending order, 2 comes up 3 times. So we will write that as 2 to the power of 3. 3 comes up twice. So that will be 3 to the power of 2. And 5 comes up once. So that is just 5 on its own. And again, a quick check. 2 to the power of 3 is 8, multiplied by 3 to the power of 2, which is 9. 8 times 9 is 72. 72 times by 5 is 360. Now for the last exam style question for this video, we've got this example here. And I hope you can see my writing here. I've just had to manually write that on. So this question states that given that 5,760 equals 2 to the power of a multiplied by 3 to the power of b multiplied by 5 to the power of c. Find the values of a, b and c. So if you'd like to pause the video here and have a go at this, we will mark it once you're done. Now this question is a bit different to the previous examples that we've seen, as this one does not specifically tell us to express a number as a product of its prime factors. It has just given us 5,760 in the form of 2 to the power of a multiplied by 3 to the power of b multiplied by 5 to the power of c. So automatically we need to think ourselves that this is a product of prime factors, and to work this out, to work out what a, b and c are, we just need to find from our factor tree the product of prime factors in indice form and then use that to identify what a, b and c are. So if we were to draw a factor tree for 5,760, now this is a large number and it has many different factors, but to keep things nice and simple, we can see that it's an even number, so we can keep one of the numbers as 2, and for the second number we can just divide here. It's going to do quick division. 2 into 5 is 2. 1 remainder. 1 remainder. And a 0. And continuing on. Again, we can do 2 as one number, and the second number can be 1,440. Splitting this up again, we can do 2 and 720. Here we can have 2 and 360. So the numbers are getting smaller and smaller as we go along. 2 and 180 goes into 360. We can do 2 and 90 here. For this we can do 2 and 45. 45 can be a product of 9 and 5. 5 is a prime number. And for 9 we can do 3 and 3, which is the end of our factor tree. Now we need to write down all of these numbers out, and because there are a lot of numbers here, we can write down indice form straight away. So starting off with the smallest factor, 2, we can see we have 2 1, 2, 3, 4, 5, 6, 7 times. So we will write that as 2 to the power of 7 multiplied by the next largest factor, which is 3. 3 and 3, so 3 to the power of 2. And the last number, which is 5, and that just shows up once, so it is just 5. Now we have got the product of the prime factors here in indice form, and as you can see it matches the format given in the question. So to answer, our values of a, b and c, a is 7, b is 2, and c will just be 1. Thank you for watching. I hope you found this video helpful. Our next topic will be on the highest common multiple and lowest common factor.